Hello there, another look at exercise 5D here for Year 12 Further Maths, and we're going to look at the products and the sum of the roots again, which we saw last time. But whereas last time we just did it for quadratic equations, today, as the slide suggests, we're going to look at cubic and quartic equations. And cubic you probably know a lot about, well, a little bit about at least, but quartic we don't really see them much in normal maths, so perhaps that is a bit new. Let's have a look at what we did last time first of all. So find the sum and the product of the roots. Now you should remember two rules. The first rule is the sum of the roots. We write this as alpha plus beta, and that's equal to minus b over a. And the product of the roots, which, assuming our roots are alpha and beta again, that's the product means they times by each other, and that's c over a. So what's that in this case? Let's just do this, alpha plus beta. So well, a equals 3, b equals 2, and c equals minus 11. So I can just pop these numbers in. So minus b over a, that's minus 2/3. Yep, that works. And I need the product, which is c over a, which is minus 11/3. One of them I had to make negative, because that's what my rule says. The other one was negative. But they're my two answers anyway, so let's just check those. Yeah, they go slightly off the bottom of your screen, I think, but yeah, they're right. So now I know what what we did last time. I've got now the rules for the roots of cubic equations, and I could go through the factorizations. They're a bit trickier, to be honest, but also you can just look at the answers and actually think they're very similar to what we had with quadratics. Just now I said with quadratic, I said alpha plus beta was minus b over a. I'm doing this so many times so it sinks in. Alpha beta was c over a. Now look, I get minus b over a again, and that was for the sum, and this is the sum as well. Look, but now I've got three roots, and you'll notice it says up here, if alpha, beta, and gamma, that's the one you might not have seen before. This is gamma. The first three letters of the Greek alphabet, that's why we use them. Alpha and beta, that's why we have the word alphabet, alpha and beta. And alpha, beta, gamma, notice if I add them together, I get minus b over a. If I times them all together, like I did last time, alpha, beta, gamma, I've written something slightly different. That's because this time we have something called the pairs. I suppose it's quite similar to this. Look at this, alpha, beta is c over a. Alpha, beta, but now there's more than one way of just multiplying those two together. I can multiply those two together, or I could multiply those two together, or these two together. So that's why you get alpha beta plus beta gamma. Notice the way it's written. It's then written gamma alpha. That's almost always written like that. I suppose a lot of you want to write alpha first, but very often it's not written like that. It's written gamma alpha. It's almost like a symmetry thing going on there. Alpha then beta then gamma, gamma then alpha. And notice though it's c over a, which is what we had last time. The new one this time is the product. It's the product of all three of them, and that's why it's new, I suppose. We was doing products there, but I've called them, these are the product of the pairs. This is the product of the triples, all three of them. So it's alpha beta times gamma is minus d over a. Make sure you've written these down. These are what you're going to be expected to know. You won't be told them. And since we've just done cubic equations, ax cubed plus bx squared plus cx plus d equals 0, make sure you've written that as well, that the fact that these only work for cubics. If you missed out the fact they only work for cubics, you're in trouble. So the other ones after then cubics are the quartics, and the quartics are very similar as much that they now say ax to the 4. So the highest power for a quartic has to be ax to the 4. So it doesn't matter what how many x to the 4s you have, as long as that's the highest power, that makes it a quartic. And notice now, rather than alpha, beta, gamma, I've now got alpha, beta, gamma, and delta. I've got 4 roots now. So because the highest power is 4, I've got 4 roots. I hope you're beginning to see the link between these things. And of course, we just cast our minds back. Initially, alpha plus beta was minus b over a. Alpha beta, of course, was c over a. It just went around like that, and cubics just extended it. But now, on these, we've got the sum now. Because there's 4 roots, it says alpha plus beta plus gamma plus delta. And this then is delta. This is the 4th letter in the Greek alphabet. Obviously, sounding like a D, so you can see where we get our alphabet from. Alpha plus beta plus gamma plus delta is minus B over A. Look, notice how it repeats itself. Notice how alpha beta, when you times 2 together, alpha beta plus. Oh, this is interesting the way they write this. I said to you before how they, on the product of the pairs, it was alpha beta plus beta gamma plus gamma alpha. But now there's so many ways of getting two of these. You can do alpha beta, you can do alpha gamma, you can do alpha gamma, alpha delta, sorry, you can do beta gamma, beta delta, or just gamma delta. Look, that's why we've got 6 of them. There's 6 different things. So they've just listed them in that order. Notice though it's still C over A. And you've also now got this new one, which is the triples. The triples is when you can multiply 3 things together, alpha beta gamma, or alpha beta delta, or alpha gamma delta, or if there's no alpha at all, it could be beta gamma delta. Notice though it's the obvious next one. It goes minus, then plus, then minus D over A, and then the last one, the product, alpha beta gamma delta, is E over A, the last number divided by A. And notice this is a plus again, it goes minus, plus, minus, plus. So I hope you've written all those down. You need all of those. Pause the video if need be. So we're going to use those now to do this example. It says find the sum of the roots, the sum of the pairs, and the product of the cubic equation. So this is what I called just now pairs. But it's the sum of the pairs. And the sum of the roots, well, we knew that before, and the product of the roots. Okay, then, so what do I want? I want the sum of the roots. So I'm going to call that alpha beta plus gamma, just to make sure that you know what I'm doing. This is the sum, and we've said that is equal to minus B over A. So I suppose I should write down A equals 2, B equals 3, C is minus 2, and D is minus 5. The signs matter, but other than that, it's just dead easy, a bit like when you do solving quadratic equations. And so it says the sum is minus B over A. So I reckon that's minus 3 over 2. That's the sum. Now the sum of the pairs, I just call it pairs. The pairs are this alpha beta plus beta gamma plus gamma alpha. And I literally have to just use my formula. My formula for this was equal to C over A. And C over A is minus 2 over 2. Well, that you can actually simplify. That's minus 2 over 2, rather, is just minus 1. It says now the product of the roots. Well, what's the product of the roots? The product, remember, was alpha, beta, gamma. And alpha, beta, gamma was minus D over A. These are the formulae that you need to learn. What's minus D? Well, that's minus 5 over 2. But what you can see, it's not hard. Well, I can't do much with that. Minus 2.5, I suppose. And what have we got here? Product. I think I missed out a minus here. So that should have been minus 5. Because it's minus... Oh, no, it's not. It's I did it right. But I did it wrong here because it's minus D and it's minus 5. Therefore, it's plus 5 over 2. So that is now right. That's right. And that's right. Okay, next one. It's a quartic. So we've now got root alpha, beta, gamma, and delta. Oh, interestingly, it hasn't asked us to find those things. I'm going to do it anyway. So what have we got? Well, first of all, I'm going to write up here A equals, just looking at this, A equals 2, x to the 4. Yep, so B equals minus 3. That's easy enough. C equals, look at this, B, look at this, 4, 3, no square term. That's cheeky. They nearly tricked me then. I was just about to write down that C equals 1, but of course there's no x squared term, so C is 0. D is equal to 1. And E is equal to minus 5. I nearly fell for that. So this is the equation then. Find the value of... Now, I know it doesn't tell me to do it, but I'm going to write alpha plus beta plus gamma plus delta. And to remember what I've said, this is the sum of the roots. The sum of the roots then is got a nice formula, which we've seen lots now. Minus B over A. Minus B is 3 over 2. I like that. Now remember the next one's called pairs. Now the pairs, I wouldn't recommend you write this, but this is what it is. It's what I wrote down just now. It's alpha, beta, plus, now I did say we stick with the alpha, alpha, gamma, plus alpha delta. So we do all the alphas plus, now we switch to the betas, we go beta gamma plus beta delta. So we've done all of those. The last one is gamma delta. What's it equal? Well, it equals C over A. What's C? Look at that. After all that, I needn't have bothered. It's 0 divided by 2. And 0 divided by 2 is 0. So then I said we had the triples. And the triples are quicker to write, but again, whether or not you want to write them all or not, I don't know. Alpha, beta, gamma. Or you could, I suppose, have alpha, beta, delta. Or you could lose the beta and you get alpha, gamma, delta. Or you can lose the alpha and you get beta, gamma, delta. What was the formula? It was minus d over a. What was minus d? So it's minus 1 over 2. And the product, remember that said alpha, beta, gamma, delta. That's a nice quick one to write. And that is e over a. What's e? That's just the minus 5 over 2. But I reckon it would have been quite easy to write that down as a triple if you've not spotted that c was equal to 0. Now look, why did I want all that? Well, it's because when I add these together, it's what you get when you multiply all these together. You get add all these together. You put them all over a common denominator, which is alpha, beta, gamma, delta. And when I do that, and I put them all over this, now effectively the 1 was over alpha, now it's over beta, gamma, delta. So on the top I have to write beta, gamma, delta. Plus, and again this one was over beta, it's gained an alpha, gamma, delta over here. So 1 times that is alpha, gamma, delta, plus. And notice I'm doing this because I haven't got a formula for this. I'm hoping when I do my bit of algebra, it doesn't look very promising at the moment, but when I do my algebra, it tidies up to something I can use from over here. So what's this one got? This was over gamma, it therefore gains an alpha, beta, and a delta. I think you probably have sussed what's going on here. Maybe, maybe not, I don't know. This last one, it was over delta, it's now over alpha, beta, gamma, delta. It's gained the alpha, beta, gamma, times by the 1 is alpha, beta, gamma. Now, what's that look like? Well, that looks suspiciously like these triples here. I think it's the same thing. So the top is equal to minus a half, and then I have to divide it by, well, look at this, alpha, beta, gamma, delta. That's the product, minus 5 over 2. You can either do it on your calculator, or you can remember that minus a half times by minus 2/5. When I turn it upside down and multiply, the minus is a minus, is a plus. The 2's cancel. I reckon it's a 5th. So after all that, I get a nice gentle answer. There it is, a 5th. Look, there's some tricks. We did this last time with the cubics. I'm not going to get all of them done, but we've got this cubic equation. I said last time we did it with cubics, I meant to say quadratics. So on this one you can factorize. You can take out 2 as a common factor, and you get alpha plus beta plus gamma. What's alpha plus beta plus gamma? Well, I suppose I can find out from up here, can't I? It's a cubic, so first thing I suppose I'm going to write a equals 1, b equals minus 4, and c equals 5, and d equals minus 6. So now I've got those, my alpha plus beta plus gamma is equal to, well, this is the sum, isn't it? And when we had the sum, that was always equal to minus b over a. And minus b over a is 4 over 4. Alright, that's easy enough, because this is now 2 times by 4 then, which is 8. I'll do this one because this is very similar to what we were just doing. If I add these things together, you end up with alpha beta plus beta gamma plus gamma alpha on the top. If you don't believe me, try me, because on the bottom I've got alpha beta gamma. Just see if you can put that over a common denominator. See if you do get this. So what do I get? Well, I've got this thing. This is the pairs. Now the pairs were something we could find. And of course the bottom bit is something we can find as well. That's the product. I'm not going to finish it now. I shall leave it till next time. And that will give me next time actually a chance to perhaps show you this in class. Still got to do this one. I'm not sure how much more there is. Probably quite a lot. No, actually that's it. We'll pick up a few questions. But we've got a little bit of practice before the lesson. Or during the lesson rather. And then before you get started we'll do those. And then And once you're good at them, we'll practice exercise 5D.